Hello guys, in this tutorial I'm going to solve question number 8, paper 11, May, June 2021. This question related with circular measurement topic. You have to know how to convert from degrees to rad and from rad to degrees. You have to know how to get the length of arc, which is theta r. Area of sector, have theta r squared, or theta in rad. How to find the angle of area of triangle, have ABC sine C. How to get the area of segment, area of sector minus area of triangle. Don't forget how to use trigonometric rules like right angled triangle, sine rule, cosine rule, and Pythagoras theorem. Let's start now to read the question. We have a diagram show that a metal of plate. The plate is made of removing two identical pieces from a circular disc with a center C. The boundaries of the plate consists of two arcs, PS and QR. You have to know where the center of the circle of each arc exactly of the original circle, and the two semicircles with P, Q, and RS are diameters. The radius of the circle with center C is 4. And P, Q, and RS is equal to 4. You have to write all the given information on the figure. If we join PQ, it's written PQ is a diameter for this semicircle, and its length is 4, and also the radius is 4. So if we join CO and CP, is it an equilateral triangle? Sure, yes. All sides are equal, so all angles are equal. The measure of each will be 60 degrees. This shape, it has a line of symmetry. So by the same way, this also triangle will be an equilateral triangle. And this side will be straight because we have a line of symmetry. So I think now it's clear how, if we compare between this shape, triangle PCQ and triangle SRQ, each will be equilateral triangle. Show that the angle PCS, the measure of this angle is 2/3 pi. 2/3 pi in degrees is 120. Look at CQ, CP, and PQ, an equilateral triangle. All sides are equal. How? It's 4, 4, 4. So this angle 6 degrees, 6 degrees, 6 degrees. By the same way, in the opposite side, 60 degrees, 60 degrees, 60 degrees. So these angles also will be equal. So the measure of each 120, 120. He asked to show that PCS is 120 degrees. It'll work out for this part. You have to mention that PQC, an equilateral triangle. All sides are equal, all angles are equal. The measure of 60 degrees, or in red, will be pi over 3. So 180, which is pi, minus pi over 3, or third pi. So the answer will be 2/3 pi. This is the first method. Or if we draw the perpendicular from the vertex, because now if we draw like this, perpendicular, this line is a line of symmetry, perpendicular to the lines PQ and SR, so the measure of this angle is 90 degrees. Isosceles triangle, without mentioning the equilateral, so this side will be 2 and this side will be 2. So if you look at this triangle, the measure of this angle, let's say we name it X, so opposite over hypotenuse. So X is equal sine minus 1, 2/4, opposite over hypotenuse. You will get the measure of this angle is pi over 6, which is 30 degrees. By the same way, this angle, pi over 6. So 180, and now 180 minus 30 and 30. but write it in red. So I will write pi minus pi over 6 plus pi over 6. You will get your final answer is pi 2 pi over 3. Same. Now I think part A is clear. You have to discuss that P, Q, C, an equilateral triangle, all sides are equal. The length of each is 4 centimeters. So all angles are equal. The measure of each will be pi over 3, pi over 3, pi over 3. By the same way, the opposite side, pi over 3. You can find it by using 180 minus or 360 minus and divided by 2, or by using trigonometry. Part B, find the perimeter, the exact perimeter. The exact perimeter, the length of outline. Let's now discuss how to get the length of outline. First, we have length of arc, and this arc represents a semicircle. So this length of arc and length of arc, it's 2 pi r. Where is r is 2? Where is r is 2? So the answer will be 2 times 2 is 4 pi. The length of arc, theta, the theta r, or circumference of a whole circle. Pi, 2 pi r, where is r is 2, so 2 times 2 is 4, so the answer will be 4 pi. What else you have? You have to get the length of, arc. The measure of this angle is 2/3 pi, and to find the length of arc is theta r. Theta r. So arc PS. Arc PS. How to get the length of arc PS? The length of arc is theta r. The length of arc theta r, theta is 2/3 pi, multiplied by r, which is 4. So the answer will be 8 over 3 pi. The length of this arc is 8 over 3 pi. And the length of this arc, 8 over 3 pi. And these two lines counted before, it's 4 pi. So the total perimeter of this shape will add 4 pi, 8 over 3 pi twice multiplied by 2. So the perimeter of this shape is 4 pi. The circumference of circle, which is 2 pi r. So the answer is 2 times pi times 2. So the answer will be 4 pi. And the length of arc is 2/3 pi, whereas r is 4. So the answer is 8 over 3 pi. So the total perimeter is 8 over 3 pi plus 8 over 3 pi plus 4 pi. They ask you to get it exact, so keep your answer in terms of pi. 16 over 3 pi plus 4 pi. This is the total perimeter of the shape. You can keep it like this, but because they are like, so you can add by getting the common denominator. So the answer 16 and 12 will be 28 over 3 pi. This is the final answer simplified. Show that the area of the plate is. How to find the area of the plate. Remove this part. Now we'll discuss how to find the area. It's clear, it's a big circle and its radius is 4. But first we cut a part which represents a segment. If we join PQ like this, if we join PQ and this part, we remove a segment. How to find the area of this segment? First, find the area of sector minus area of triangle. First, we'll get the area of segment, which is outside segment PQ. How to find the area of this segment? Area of sector minus area of triangle. And we'll double it because are same. There is segment to complete the whole circle. How to find this segment? It's identical, exactly same. Find the area of sector minus area of triangle. What else we removed? We removed a semicircle up and the semicircle down. Then it's removed from the whole circle, which is pi r squared. So first step, find the area of segment PQ. How to get the area of segment? Area of triangle minus area of sector. The measure of this angle is pi over 3. This side is 4. This side is 4. So find the area of sector minus area of triangle. The first step. Have AB sine C, so the area of triangle, minus have theta r squared, this is the area of sector. So have times 4 times 4 times sine angle included, which is pi over 3, minus have theta in red pi over 3 and r squared, which is 4 all to the power of 2. So area of triangle, sorry, I switched the order. Area of sector minus area of triangle. Switch the order. Area of sector minus area of triangle. You have to write the big value minus a small value. If by mistake, like me, and get this value in the final exam, don't waste your time and just switch the order and write a negative sign, remove it to be positive. So the area of sector, first, the big one, have theta r squared minus have AB sine C. So have angle pi over 3 into r, which is 4 squared, minus have times 4 times 4 times sine 6 degrees or pi over 3. Don't forget, in this part, use angle in red system. You have to write, to change your calculator system and write it in red. Then calculate, this answer will be 4 squared 16. 16 multiplied divided by 2 will be 8 over 3 pi. 4 squared 16, half of 16 is 8, 8 over 3 pi, plus, minus 4 times 4, 16, half of 16 is 8. Pi sine pi over 3 is square root 3 over 2. Simplify, so 8 over 3 pi minus 8 divided by 2 is 4 root 3. This is the area of segment. What else you have to get? Find the area of semicircle multiplied by 2. I will get area of one circle. Area of the small circle, pi r squared. Where is pi? Keep pi. But the radius, the radius of the smallest circle is pi is 2. The radius of the small circle is 2. So 2 squared. So the answer is 4 pi. If you simplify, this value will be 4 pi. Now, find the area of the whole circle minus the area of sector, area of segment, and the area of semicircle. So the total area will be area of big circle, pi r squared. But now r is 4. So pi times 4 squared will be 16 pi. This is the area of big circle. Minus, remove what? Remove segment. This is the segment. Times 2 will be 2 multiplied by 8 over 3 pi minus 4 root 3. This is the area. What else we have to remove? The area of circle, which is 4 pi. Try to simplify your answer. 16 pi minus 2 by 8 is 16 over 3 pi. Minus 2 by 4 is 8 root 3. Plus 4 pi. Simplify more. 16 pi minus 16 over 3 pi plus 4. Calculate it. Then keep your answer exact as it's. We continue to simplify the answer. When we multiply 8 over 3, it's a negative sign, but negative times a negative is positive. I forgot this part, and the negative times a positive will be negative. So this answer will be negative. Now, we'll add all the like terms included by this part and this part. It's 16 pi minus 16 over 3 and minus 4. So the answer will be 20 over 3 pi plus 8 root 3. This is the exact value. He asked it to show that. I think it's 20 over 3 pi plus 8 root 3 centimeter squared. So in this question, as I told you before, you have to know how to get the length of arc and how to get the area of segment, area of sector minus area of triangle. In case if we have an equilateral triangle, so each angle will be pi over 3. Thank you.